Okay, so section 5.6 is complex zeros. In section 5.5, we learned how to find all of the zeros, all of the real zeros of a polynomial function. So now we want to know how to find all of the zeros, real and complex. And actually, the word complex includes real numbers. Okay, first though, we need to review complex numbers, or rather, imaginary numbers. The imaginary number I was created to represent the square root of -1, and it allows us to solve for zeros in a polynomial that would not be solvable otherwise. It allows us to solve problems using algebra, and even some real-life problems. If you didn't have imaginary numbers, you wouldn't be able to eventually get to a real answer without first being able to work with the imaginary number answers to get there. Okay. So I represents the square root of -1, because we can't take the square root of -1, so instead of writing this, which is impossible, we replace it with I, which we do consider possible, even though it's kind of a strange concept. Because of that, when you square a square root, so I squared would be the square root of, would be squaring the square root of -1, that's just going to equal -1. So you would always simplify. Anytime you see an I squared in a problem, you always replace it with a -1. You should never have I to a power. You should always simplify it somehow. In fact, I to the third can just be written as -I, because it's like -1 times this. And I to the fourth can be written as why am I getting confused? Oh, I to the fourth can just be 1 because it's -1 squared, and -1 squared is a positive 1. And then this cycle just repeats over and over and over. So if you have something like I to the 17th, that means it is I to the 16th times I. Well, I to the 16th, 16 is a multiple of 4, so it's like I to the 4th times I. And of course, I to the 4th is 1, so 1 to the 4th is just 1 times I is plain I. So we're able to simplify any exponent on I to simply I, -1, or +1, so that I will never have a power. Okay, let's look at some things that we use complex numbers for. First of all, complex numbers allow us to solve something like this, where if we have x squared plus 4 equals 0, we could solve that by moving the 4 over and then square rooting both sides. So x would be the plus or minus square root of -4, which previously would not have been possible. But now we can call it plus or minus 2i, because we have the square root of 4 is 2, and the square root of -1 is I. So that is our complex answer. Okay, complex numbers are written in two parts. You have your real part, and you have your imaginary part. So if you actually have a real number, that still is considered a complex number, because a real number would just have a real part plus 0 imaginary part. Okay, it still can be written as a complex number. Alright, so here's some complex numbers. Oh, so typically we call it, like we're writing it in this form, a plus bi, where a is the real part of the number and b is the imaginary part of the number accompanied with an I. Notice how there's never an I squared, I cubed, I to the 4th, it's always just I. Okay, we can add complex numbers like 2 minus 3i, notice how that fits our format, plus 6 plus 8i. And we should always, when we're adding or multiplying or anything complex numbers, get another complex number. Or a real number sometimes, which is a complex number. Okay, so we combine like terms. 2 plus 6 is 8, and -3i plus positive 8i would be positive 5i. So we've taken two complex numbers and created a new complex number. Similarly, we can multiply complex numbers. When you multiply complex numbers, you have to FOIL. And I wrote down the wrong problem. That was the one we just barely did. Let's do this one instead. 5 plus 3i times 2 minus I. So we're going to FOIL that whole thing out. So 5 times 2 is 10. 5 times negative I is negative 5i. 3 times 2 is 6i. And 3i times negative I is negative 3i squared. So that gives us 10 plus I minus 3i squared. But what did we say earlier about the I squared? We can replace that with a negative 1. So negative 3i squared turns into positive 3. So now we can combine the 10 and the positive 3 together, which is 13 plus I. So we have our real part ends up being 13, and the imaginary part is just one simple I. So anytime you have an I squared from FOILing out complex numbers, you change that to a negative 1, multiply that out. Your negative times your negative is a positive, or positive times a negative makes it negative. Combine those like terms together, you've got your imaginary part separate, and you've got your new complex numbers. Your new complex number with no exponent.